We would like to move now to my colleague Adrian's presentation on the traversal approach. Here we'll be delving in, admittedly, to the programming level of the report templates. So this may be very new to some of you, but at least it will be some level of introduction into what is required for the report templates. And indeed, we can answer follow-up questions after the workshop if you have any, so that we can support you in your report building. So I'll hand over to Adrian now. Thank you.
Okay, so well, hello everyone. My name is Adrian. I work in EFSA, as I mentioned at the beginning of this workshop. And in the last years, I've been working developing some templates for report generator for pesticides applications. So in the next slides, we'll try to explain to you one of the methods we use to generate some of these reports, which we call the traversal approach. And as Mark was mentioning, it's going to be quite technical, but it will go from less technical to more technical, so that it could be more interesting to the most of you, at least part of it. So this is the method we use, for example, or is the method we would like to apply to the extended literature references report that we were talking about before. And before I start going into the method itself, I would like to review a couple of characteristics of Euclid that you probably know by now, but that is important to keep in mind in order to understand how this algorithm works. Okay. Yeah, okay. So the first thing I would like to review is actually IUCLID's data structure. As you probably know by now, a dossier in Euclid has a tree structure. So we start with a table of contents that has different nodes at different levels, as you can see here in this picture. So we have at the very top the dossier header and then the product. This is our main mixture, and then from there we can expand the different sections and subsections. And as we can see, we have different node levels. So the root would be our mixture. That's the level 0. And then we have different sections at level 1, 2, 3, and so forth. So the root of a dossier is always either a substance or a mixture data set. In this case, it's a mixture. And in each of these nodes that I was highlighting here, we can find a number of documents. So for example, here under the node, which is a level 2 of detailed quantitative and qualitative information on the composition of the plant protection products, we have 2 documents of the same type, which is the mixture composition. So this is part of the tree structure of Euclid. But on top of that, as you probably know by now as well, within a table of contents, we can link other data sets. For example, an active substance data set within a mixture. That creates a new table of contents. So this creates this nested structure of Euclid. So a new table of contents, again, with different nodes at different levels and different documents at each node. And finally, in addition to this, if we go to individual documents within a node in the table of contents, we see that actually the document has also a tree structure. So as I'm showing here in this picture, the document for the composition of the plant protection product is the one that you see there on the right side. And there we can also classify the different fields that we see into different levels, okay? So all in all, so that you keep in mind, IUCLID has this nested tree structure with different tables of contents at different points. And also for each document, we also have a nested structure, okay? And this is something we have to bear in mind to parse the contents and to create the reports later on. Another characteristic of Euclid that I wanted to review is what is an entity. So entities are building blocks in Euclid's data model. And the important thing to bear in mind is that we have 2 different types of entities: composite and simple entities. Composite entities are the most complex ones, and this is where we have mixtures, substances, or categories, for example. And basically, they all have a specific document which summarizes some information of the entity. Here in the picture, you see the document for a mixture. But the important thing of these entities is that they have a table of contents with documents, okay? So you can attach different studies within these entities. In contrast, a simple entity, such as a reference substance or a literature, a legal entity, and so on, they are just a single document and you cannot attach studies or anything of the like to them. So they are quite different in their complexity. All right, so this was more of a reminder. Probably you had seen that before. And now going back to the actual traversal approach, this is the approach, as I was mentioning before, that we use for some reports, which we call the list reports. These are reports that extract specific data from different sections of the dossier into tables or lists in PDF, RTF, or CSV format. We have many currently, and you've seen them probably. An example is the list of confidentiality claims. So you get a table with all the claims made throughout the dossier, the list of literature references or the extended literature references report, list of attachments that lists all the attachments that the applicant has introduced in the dossier, and so on. We know that these reports are quite heavily used. We also use them in EFSA or in ECA because basically they allow us to visualize, compare, and filter data, which is very cumbersome in the graphical interface of Euclid. And in the next slide, I will make an example of this case. So for instance, for a literature references report, as you know, a literature reference is introduced in the data source field of studies, as you see there in the picture. So we have the data source and the field called reference. There we link our literature reference that you see on the right that contains information on the type of reference, the year, the author, and so on. Now, this is introduced for all the studies or most of the studies in the table of contents, so it's very hard to compare if you look at the interface in Euclid, because you would have to click over many different sections of the dossier and you cannot have a direct comparison. So for that, we create these reports that, as Mark was explaining before, display one row per reference and include some other additional information so we can compare easily all the contents. Okay, so this is why we use this traversal approach. And now I'll get more into that. So in order to generate these kind of list reports, we need to create an algorithm that basically goes through all the different nodes in the dossier tree. So what I was explaining at the very beginning. The code should check the main table of contents, but also every table of contents of the linked datasets and each document's tree structure as well. Initially, before last year, we had some code that was more or less doing this, but it was heavily hard-coded, meaning that the code contained the specific instructions saying, look into this specific data set, a mixture or a substance, this specific node, this specific document. And then based on that selection, then retrieve the relevant information that we are interested in. The problem with this that we encountered with this approach that we were using before is that whenever there was a format change, depending on the format change, of course, but very often, then we needed to adapt the code. And I will illustrate this. Imagine we have a report that is extra. We have a dossier that usually contains one mixture with one active substance. And then we have a report that is extracting information from this main mixture and this active substance. And this selection that the report should extract this information is very hard-coded in the code. This means, and actually it meant in practice, that if we make a change format in our dossier structure and we introduce a new section, as it happened for pesticides, called other representative products, where the applicant can link additional representative products, in the version of the code we had before, the code would ignore any information introduced in those newly added datasets, okay? Because initially we were just focusing on the main mixture and one active substance. So this is a problem because we need to adapt the code almost every time there is a big format change. So to overcome this limitation, we developed together this so-called traversal approach. So in this case, instead of defining in the code which datasets or which nodes, documents we're going to be using to generate the report, the algorithm basically looks into all the datasets, nodes, documents that are included in the dossier. So irrespective of which kind of dataset or document this is. So So we've been working on that, and we have modified some of the existing reports to apply this new traversal approach. Of course, the pros, as I was mentioning before, is that this is more standard. So we use actually the same common code for many different list reports. And especially it is important because it's more insensitive to format changes and it's more flexible. It does have some cons though. And the main one is the performance, because since we are creating an algorithm that goes through all the contents of the dossier, then it becomes a bit slower. For smaller dossiers, this doesn't have a big impact. So the pros outweigh the cons by far. For very large dossiers, which we have sometimes for pesticide applications, it can really get very long. So that's a bit the main drawback. I will not go into those details, but we will be looking into that to try to improve the performance of these reports by maybe building some built-in functions or some, modifying more the back end of how IUCLID works. But for the moment, this is the situation. And the code, well, this is a bit debatable, but it might be a bit more complex. But as I said, since it's reused across different reports, then, okay, a user doesn't necessarily need to understand the code in order to apply this algorithm, as I will show later. Okay, so now I'll dig a bit into the actual code that this approach uses. So this is getting, as I warned you before, more and more technical. So this traversal approach uses several FTL templates. And here I'm highlighting the two main ones that I would like to explain a bit more in detail. So within the report, we would find some common modules. And the important one is the common module of the traversal utils that is called here, which contains the common macros and functions that this method uses. On top of that, sometimes we have other common modules, as Mark explained this morning, such as the macros common general, some common module for the front page, and so on. So that's a bit depending on the report. But the common module for the traversal utils is always there. And on top of that, each specific report will have their own main FTL, which basically imports the other templates, contains the call to this traversal approach, and contains other specific instructions for the report. So I'll talk a bit more about these two separate modules. So starting with the common one, what does the common module for the traversal do? So basically contains a set of macros that, as I said, are common to all the reports using this approach. And they don't need to be modified. So you just have to use this module, but you don't need to modify any code that is there. These macros that are written there, they call each other sequentially and recursively so that they go through all the nodes in the tree, as I explained before. And I will not mention all the contents of this template because it's quite complex, but I will mention a bit about the first macro and the last macro of the sequence. And here on the right, you see actually the flowchart of what this does, so how the algorithm works. So the first macro in this module called traversal initiates the process. So we only have to pass one argument, which is the entity, the first entity we need to start traversing. And this is usually the root, so our main mixture, okay? Then once the process is initiated, then we go into a set of loops as you see in the right, okay? So if there's an entity in our initial list, which initially contains the root, as I said, then first we need to check if the entity is composite or not. If it's a simple entity, as I mentioned before, it means it's only one document. So we just need to traverse this document. And only if we find new entities there, we would add them to the list to be traversed. However, if the entity is composite, as I mentioned at the very beginning, then we need first to extract the table of contents, go through every node, go through every document. And for every document, we call the other macro traverse doc. So again, we traverse the document, we add the entities to the main list. Then in the next iteration, the code will check if in our new list of entities, there's something. So because we found during our traversal approach, some new entities that we need to consider. If there are more entities, the process repeats. If not, it ends and we get our output reports. To remember is that the first macro, this traversal, needs to be called in the main template. I will explain this a bit later. And the traverse doc macro, which is the last one of the sequence, which goes through the document, basically calls a specific macro that is the one containing the instructions of what specifically we need to extract for each report. For example, we'll call a macro to extract confidentiality claims for the confidentiality claims report, or literature references for the literature references reports, and so on. So to bear in mind these two things, the traversal needs to be called in the main template. The traverse doc will call a macro that we will need to define also to extract the specific information. Here is a bit of the same that I explained before, but you see a bit how the loop, the code looks like. So I don't think I'm gonna go into the details, but I will leave the slide there for you to check how the actual code for a macro looks. In this case, it's the first macro that I was explaining, the traversal, and you see how there we define the loop and how for each iteration of the loop, an additional macro is called for each entity. Again, I'm not going to go to the details, but I leave it there for you for your information. Same for the last macro I was mentioning, the traverse doc. And here you see there are two things in this main macro that you see in the code, which is the main macro call, which is the macro that we need to call that extracts the specific information for each report. Again, I leave it there for your information if you want to have a closer look to it, but I will not get into the details. Okay, so that was for the common module. Again, I repeat, it doesn't need to be modified. It works pretty well like this. But now the other important part to have a look at is the specific module for each report, which is the main template. This main template, and this is what the user needs to create for each specific report, needs to contain 3 minimum parts. Of course, this template needs to import the other templates that are going to be used. So for example, here we will be importing the common module traversal utils, okay? Because we're going to use the traversal approach. The second element that needs to be there, as I mentioned before, is a definition to the main macro that is going to extract the relevant information we need. For example, if we're talking about the confidentiality claims report, we have a macro that is called primitive data protection element node, right? That will contain some instructions on the extraction of the confidentiality claims. And importantly, for those developing the report, this macro in the code needs to be made a global variable, such as in the right. Global variable means that it will be available to the other modules that we're importing as well. But this is something that we have to keep in mind. And finally, what the code has to do is to call the actual traversal approach. So this is a very easy call. You just write, in this case, utils.traversal, and you pass the root entity to start the process. So this is the important part for those developing reports, because this is the part that needs to be created for each specific report, okay? It needs to contain these 3 main parts. On top of that, then, of course, this main template will contain any other macro function you will need to create your own report. But this will allow the usage of the traversal approach. Okay. And just when building this kind of reports, I wanted to give you also a few hints. There are some built-in functions in FreeMarker or Euclid that have already been developed and are very performant and can help to do some tasks. There's a list in the FreeMarker documentation. You can check the hyperlink there in the manual. And there's also another list in the IUCLID website. These are usually functions that are called IUCLID.something. And again, this can save a lot of work, because instead of you creating the code to perform these tasks, sometimes, I mean, you can just use them out of the box, and you don't need to worry about coding this part. And these are some examples. And this is something that we will be working on in the next days. There's a built-in function called hasElement, where you have to pass, that is applied to a node, and you have to pass a name of an element, and basically checks if a node contains a specific element as a child. So for example, here in the image you have there, you have test animals that contains species and strain. We might not know if a specific endpoint study record, for example, has this field or not. So in order to code this in an unbiased way and not to care for specific cases, we can call this built-in function, test animals has element species. So if it has a child called species, then we do something. If not, we just ignore. This avoids us writing different if conditions, such as saying if the endpoint study record is acute toxicity, you do it. If it's a repeated dose toxicity, then it doesn't exist, don't do it. So it's a bit more unbiased and helps streamlining the code that we need to write. Another important built-in function is has content. So basically checks if an element has content, not if it exists, but if it has content. For example, in this case, species is empty. So if we call this function, the output would be false, or it doesn't have content. And node type is also something that we'll be using, and it's being used in the traversal approach a lot as well, which is to check the data type of a specific element. So you can say test animal, for example, node type, and the output would be pick list. For our species would be a pick list. So you can understand what kind of data type you are dealing with. Sorry. With this, I'm sorry, I realize this has been very technical, but okay, you have the slides, you can come back to that. But if you need to use the traversal approach, I believe this will help you understand how you can start building your report using this approach.